Hello, today we will give you information about our graduation project. Our project, Sound Sensitive Maternal Movement IoT Grip. Our disease advisor is Dr. Mohammed Garib. Our project team consists of two people, Rıdvan Çelik and me, Ahmet Dağtepe. Our presentation consists of four parts: introduction, product, function, progress. Our first part is introduction. Project definition and motivation. In today's conditions, women can work in more jobs than in the past. In this situation, both parents can work. As a result, both of them are very tired. Babies usually spend most of the day sleeping. Our project, which we think can be of great help to parents who have difficulties in putting their baby to sleep, will be of great help to them. You can control it from the phone. It works easy. You can see your baby on the phone. The baby sleeps better. Another issue is that it is one of the first tools people use when they are born, which is also a source of motivation. Scientific research and experts warn that the baby sleeps in the cradle, ABC, alone back crib. The baby should sleep alone on his back and crib. After deciding on the project for the infinity sign you see in the middle, we observed that it draws an infinity sign while collection data from mothers about shaking babies. It represents the bond between the baby and the mother, so we made our design accordingly. Scope. I would like to talk about the scope of our project. First of all, it has a different design from the product we found while searching the literature. In this way, it is easy to use when interacting with the phone over the internet. It is safe. When the mother wants to see her baby, she can open the application and see her baby through the camera. It monitors the environmental conditions, for example, the temperature of the room, the width of the crib, and the surrounding noises. It can play loaded tunes for easier and more comfortable sleep. It has automatic operation features depending on the baby's crying sound.
You see here six of our important technical specifications. Temperature should be between 20 and 24 centigrade. Humidity should be between 30 and 16. These are checked by Baby Health Care Service. Baby cry sound can increase up to 120 decibel, and we specified after 30 to send notification. 60 fps camera for increasing parents' free time via monitoring. Enough size baby to balance their sleep, and accessible price for the crib. We produce at all two products. One of them our main product, which is crib. We plan to bury the electronic parts there using MDF material in the body. The camera will be placed at an angle in the position to see baby. Microphones will be on the sides to get voice. Our second product is mobile application we designed through MIT App Inventor. From the application, we will be able to observe the baby, hear its voice, and operate the crib. It will also provide the opportunity to follow environmental conditions instantly.
Our third part is function. Grip mechanism. We made the cradle we designed before suitable for production according to the revision and started production. Since it will be a composite production, this will consist of MDF aluminum pipe plastic profiles. There are robot arms on the bottom layer to move the motor and mechanism. There is also bearing on its top layer. Apart from the one we have prepared in MSD, we will add 4 wheels to reduce friction and make it move more easily. We apply Grashof theorems for our mechanism first to our calculations due to the reproduction we have made. We calculate the angular position of the crank with the equations you have seen. We calculate the position of the initial and final position of the rocker with the equations you have seen here. Theta for I and theta for F are the first and last position of the rocker link from which they can be calculated by equations, and finally the swing angle can be calculated by derivatives of these angles. We did the position analysis with our new values with the equations you have seen and created results in table. Velocity analysis. When we compared the results of each angle and output in Excel with the sensor outputs of the roadmap of the mother's shaking motions that we received and collected in the mechatronic system design lesson, we corrected those sensor outputs to the sinus curve by applying the sum of sine rule we learned in the numerical methods lesson and compared this output with the data we have.
When we come to the black box diagram, we will have three inputs and three outputs in the system. We have linked these inputs and outputs to the modules, and each module has its own algorithm and operation. We connect all of these modules to our controller, which is Raspberry Pi, and communicate with the mobile application through this online server. The online server is thanks to Google Firebase.
Voice sensor. The subject I am currently working on is detecting and filtering the frequency of the baby voice. We will do this with the electret microphone and LM386 circuit you have seen before. LM386 is an audio amplifier circuit. It works with low voltage, so we choose this circuit.
We will use the temperature and humidity sensor, which is one of our environmental quality sensor, only for observation purposes, so that we choose a module that is available on the market. Since we didn't need a very sensitive data, we decided that DHT11 would do our job thanks to the comparison. This module allows us to observe the data it collects from the mobile application by delivering it the server database instantly via Raspberry Pi, and it warns when necessary. We use the camera to observe the baby. The data we collect reaches the server through the Raspberry Pi, and the user can make instant monitoring through the mobile application if she or he wants. If we talk about the progress, this study is supported within the scope of TÜBİTAK 2209A. From our work so far, we have produced the body through the MDF as well as the bed and the bed protection through the 3D printer with PLA. In addition, the production of the mechanism in the body took place. We follow up the works we divide in the work breakdown structure by using Trello project management application. As for the roadmap, we plan to complete our work at the beginning of December by using the simulation background information we prepared at Mechatronic System Design. Our detailed roadmap is shown here. Thank you for listening to us.